Hello and welcome to Topic 16, Standard 1. This is all about classifying and multiplying polynomials. So the first one is all about, can you classify and do you know what standard form is? So standard form is taking each of these terms and rearranging them so that the highest exponent is the one that starts on the left and it decreases all the way to the right. So you do not want to confuse that with the coefficients, because here this is a 7 power 5, 4, 2. Notice they're already decreasing. 7 is the biggest one, then 5 is the next biggest, then 4, then 2. It's already in standard form. So I literally can just take this and write it on here. 6n to the 7th minus 2n to the 5th plus 5n to the 4th minus 3n squared. Okay, so do not mix it up with those big numbers in front, which are coefficients. Then it says classify by degree. Degree is the highest exponent, which in this case is a 7, but there's a name for it. So you have a table, you're allowed to use the table. It starts with constant, linear, quadratic, cubic, quartic, quintic, 6th degree, 7th degree, 8th degree, 9th degree, 10th degree, so on forever and ever and ever. So since this one doesn't have a fancy name, we just write 7th degree. Okay, and then lastly, classify by the number of terms. So terms are determined or separated by plus signs and minus signs. So if I put slashes between the plus signs and the minus signs, I have 1, 2, 3, 4 terms. And again, you have a table for this. If there's one term, it's a monomial, 2 is a binomial, 3 is a trinomial, and then 4 or more is just a polynomial. They were like, I'm so tired. I don't want to keep going forever. Let's just call it a polynomial. So this is standard form, and it's known as a 7th degree polynomial. Okay. Now we're multiplying polynomials. So the first one, by monomials. So what we have here is a monomial outside of a polynomial. And what we want to do is take this guy, and it's kind of like what I call the mailman method. You send it to each term. So when you do that, you do what we did before, which is like number times number, x's times x's, y's times y's. So 3 times 4 is 12. This is an x to the first, so I have 1x here and 2 here, that's x cubed. And then between these I have 1y. That's the first one. Then this one, 3 times 5, that's positive 15. And then here I have 1x and 1x, x to the first, that's x squared. And then I have y to the first, that's y squared. And then this last one here, this is minus 1 in the front, so 3 times negative 1 is negative 3. Between the two, I just have this x to the first, so I'm going to write x. And then I have y to the first and y squared. Well, that's a total of 3 y's, so that's y cubed. There you go. Notice not a ton of work to be shown, but that's okay. Then same thing over here. Notice there's only one variable this time. So negative 2x, we times that to the first thing. So that's a negative 2, and then there's 3 x's between the two of them. Then negative 2 times 3 is negative 6, and there's 2 x's from those two terms, so x squared. And then the last one, negative 2 times negative 8 is positive 16. And don't forget, even though the 8 doesn't have an x, this one does. So you have to bring that x with it. Okay? Non-negotiable. And there you go. Okay. Now, here, you multiply polynomials times each other, so 2 or more terms. And you can use any method. Notice I gave you boxes and I wrote optional. I'll do one with the box method and one with what I call the mailman method. So I'm going to do the mailman method first, and that's where the first of the parentheses I'm going to call the negative 3x a mailman. And he's going to go to every house in the neighborhood. So I multiply. Negative 3 times positive 3 is negative 9. X times x is x squared. Then he goes to the other house. There's only 2 houses in this neighborhood. Negative 3 times negative 6 is positive 18. And between the two of them, there's just 1x. Then we have our Amazon Prime guy, and he's plus 2, and he goes to each house. So I do 2 times 3x, so 2 times 3 is positive 6 and an x, and then 2 times negative 6 is negative 12. So I want to see this step. No matter what method you use, there should be an intermediate step, but then I'm not done, because if there's like terms, I combine them. So notice I have an 18x and a 6x. Those are the exact same variables with the exact same exponents. I can bring those together. 18 plus 6 is positive 24x. And then you can just bring everything else down. Minus 12 and bring down the negative 9x squared. Again, not a ton of work, but there is 2 steps. Okay? Now, you can show this step in the box instead of in a line, so I'll show that over here. So to use the box method, what you do is you use the polynomials as the side lengths of your boxes. So since there's only 2 spots here, I'm going to use this. 3x goes here and 4 goes here. And then along the top, we'll have 4x squared, 3x, and 2. Okay, so now those have made the 2 side lengths, because when you multiply side lengths, you get area, and here, what am I doing? Multiplying. So, now, as I go across the first row, the 3x will multiply each of these. So, 3x times 4x squared, 3 times 4 is 12, and then between those, there's x to the first, and then 2, so that's x cubed. Okay, then 3x goes to the second box, times 3x. 3 times 3 is 9, and then x to the first, that's x squared. And now 3x is on my last row, or my last box, 3x times 2, so 3 times 2 is 6, and then between those, there's just 1x. Okay, so it's kind of like your mailman going to every house, but it's in a box instead. Then I'm going to do the same thing, but with the 4 on the bottom row. So when I go to the 4, it's going to multiply this 4x squared. 4 times 4 is 16. And then between the 2, there's just an x squared. Then I have 4 times 3, because we're on this one, that's 12. And between the 2 of those, we only have 1x. And then lastly, we get to this last box, 4 times 2 is 8. All right. So now what I want to do is look to see, are there any like terms? Well, this is an x squared and that's an x squared. So these 2 things will be combined. And if I look at 6x and 12x, those are also like terms because they're x and x. Now notice this 12x cubed doesn't get to be combined because it has a different power. You always have to have the same power. So now I'm just going to go through and write them all as addition. If it's a negative, it'd be subtraction, and combine the terms as I go. So I have 12x cubed. And then I bring those together. They're both positive, so that's nice. 16 plus 9, that is what, 25? So plus 25, x squared. Then I have these 2 guys. 6 and 12 makes 18 and x. And then my only guy left is this plus 8. So notice here I have the extra line as a line of work and then the solution. And then over here, the stuff in the box is the work. And then I combine the like terms, and now that is my solution. And there you go.